Nice. Creamware. A very pleasant tea-drinking vessel. The man who first made this genteel crockery was a hero of the Industrial Revolution. Engineer, scientist, marketing genius, Josiah Wedgwood turned cups and saucers into an international business empire.
The Wedgwood factory, near Stoke. And something we all take for granted, a production line. Consistent quality on a massive scale. But over 200 years ago, when they first started making this creamware, the idea of factory production was revolutionary. Where did it all begin?
Like most things, it comes down to fashion. In this part of the country, you don't have to dig very far before you find red clay. And for centuries, it was a potter's dream, the raw material that made Stoke the centre of the pottery trade. But by the 18th century, heavy red earthenware was out of fashion. The new middle class and the gentry wanted white or creamware, and they wanted it in vast quantities. This new product used powdered flint for colour and texture and was made of white clay and stone from Cornwall and ball clay from Devon and Dorset. And creamware was the speciality of Josiah Wedgwood, master potter, inventor and one of the great entrepreneurs of the Industrial Revolution. Wedgwood didn't invent creamware, but it was his use of scientific method that turned a small-town trade into a modern mass-production industry. Wedgwood built his factory at Etruria here in the middle of Stoke, and he lived above the shop. That's his house, up there. And the canal he overlooked and helped to finance took his crockery all round the world.
By looking at the old-fashioned way powdered flint, one of the key ingredients for creamware, was produced in Wedgwood's day, you can see why his newfangled production methods were so revolutionary.
This is a flint-burning kiln, the first stage in a process to turn flint into hard, white, fine powder. This kiln would have been filled with alternating layers of flint and small coal, peas, beans and slack, if you know your coal sizes, then heated from below to over 1000 degrees centigrade.
One man did all the work.
Right, I've got my flint from the kiln into the mill, and now I need to get it up there.
There was no production line, no division of labour, just a miller and a massive water wheel.
Power! Right, I'm now on the grinding floor, and I'm going to bring my flint up using this, which is a power takeoff from the water wheel, and it's still a one-man operation. We foot in there and connect that. You can hear that there. Up it comes. Very, very simple. Marvellous. I've never lifted so much in my life. Then shovel the flint into this, the grinding pan, where it was ground between two sets of stones for 2 days. And this pan would have been full of water. They tried dry grinding, but it killed too many millers. The dust. They called it potter's rot.
Ingenious machinery allowed the flint miller to work alone, but his output would always be limited. For his new pottery business, Wedgwood was thinking on a grander scale.
One man doing every job wasn't going to build an empire. What Wedgwood dreamt of was one man doing one job. Men working as machines. Each part of the process separated and controlled. His ideas transformed the layout of potteries. This was the only way in or out. It meant that management up there could keep a very close eye on what was going on. security, quality control, consistency.
This is the start of the production line, the slip house, where the flint and the clay were first mixed together.
Raw materials would have been assembled, weighed, filtered and purified in here. Precise measurement was part of Wedgwood's scientific approach. Of course, this is a 19th century steam mechanised version of what in Wedgwood's day would have been done by hand or by water power. This next stage, wedging to remove air bubbles, is back-breaking work, but originally would have been done by women and children. That's enough of that. And this work would also have been done by women and children, turning this big wheel in order to turn this little wheel. This is exactly the type of wheel that Wedgwood would have used. He was, after all, a master potter. He believed in experimenting himself, creating new styles which were copied by his team. Mass production. Keep going, I'm having a good go here. But you can't put this lot straight into a kiln. You have to make a protective container known as a sagger. And this job is known as sagger maker's bottom knocking. Everything is laid out in logical order, leading to this, the bottle kiln. It took 14 tons of coal and 48 hours to fire one of these up to 1200 degrees centigrade, and each one could take over 2,500 saggers. I would not like to have to fill one, and I would definitely not like to empty one. This is where you could make or break the business. Get the temperature wrong, and you could lose a whole kiln full. Get the temperature wrong twice, and you could go bust. The traditional method was to put clay pieces in the kiln and guess the temperature by the amount your clay contracted, but this wasn't good enough for Wedgwood the scientist.
He wanted perfection, carrying out thousands of tests to see how variation in heat affected his creamware. He logged all his trials and kept elaborate encrypted records in his secret experiment book. Every sample was stamped with a code, giving its precise position in the kiln.
In Wedgwood's day, there was no thermometer in existence that could withstand temperatures above 360 degrees centigrade. And this kiln was fired at over 1,000 degrees. So, by detailed observation, he developed a simple but very accurate gauge to measure precisely the contraction of clay samples and therefore temperature. His pyrometer was the breakthrough that gave him the consistency he needed, and he was invited to become a member of the Royal Society. As a gentleman who was likely to become a useful and valuable member. At work, Wedgwood was obsessed with detail and discipline, and he was equally strict with his own health. I ride 10 and 20 miles a day, and by way of food and physic, I take whey and yolks of eggs in abundance, together with a mixture of rhubarb and soap, and I find the regimen agrees with me very well. If you have any doubt about the inventive genius of Wedgwood, look at this. It's a lathe designed in 1764 by the man himself, and it's still working here at the new Wedgwood factory. It uses an eccentric cam operation to cut patterns into flatware. It's funny how some simple things endure. Surrounded by computers, we still use pencils. His scientific approach to production made Wedgwood a very wealthy man. He was also a marketing genius. His breakthrough came when he sold a creamware service to the Queen. From then on, he called it queensware and styled himself Potter to Her Majesty. Soon he was making 1,000-piece dinner sets for the Empress of Russia. He had put Stoke on the map. What he now needed was a transport system to match. Wedgwood's revolutionary new methods of production depended on him being able to bring in his raw materials in bulk and then transport the finished, fragile goods safely and smoothly. But the roads in the potteries were notoriously unreliable. Many a potter, when clay supplies ran low, would simply dig clay up from the road outside his works. One traveller fell into a rut 4 foot deep. Shades of Dr. Foster. So, in the early 1760s, Wedgwood lobbied for a canal to be built from his works to the Trent in the east and the Mersey and Liverpool docks in the north. Flint in, clay in, fancy crockery out. For architect and engineer, he turned to James Brindley, who had already designed a successful flint mill for the Wedgwood family. Now he was the leading canal builder of the day. He had a vision of linking the 4 rivers, the Severn, the Thames, the Trent and the Mersey, in a grand cross of canals. This was to be stage 1. Some 93 miles long, it became known as the Grand Trunk. Brindley had some strange habits. We like our geniuses to have strange habits. After looking at a potential route of a canal, ocular surveys he called them, he would often retire for days on end to a darkened room when confronted with a particularly difficult problem. Like this. Harecastle Hill rises 30 metres above the only possible line of the canal, blocking the route to the Mersey in the north. Brindley's darkened room decision was to tunnel. Apart from tunnelling through rock, hard and soft, coal and quicksand, Brindley had some serious surveying problems to overcome. This is one end of his tunnel. The other end, 2 miles over here, is out of sight. And this is the other end. There's a pole here and a pole 2 miles away. So there's no sat-nav, no aerial photography, no mobile phones. How did he work it out? Well, he used a system called double ranging. OK, with the help of my friend Vic here, we will demonstrate some 18th century magic. If we keep aligning our poles, one with each other, like this, eventually all the poles across the hill will be in one unbroken line. We've only got 2 poles to align with the marker pole behind us. Brindley's men would have had about 50 to line up, 2 at a time. It may look a bit hit and miss, but it works. We can now sink our shafts. 15 in all in this case. So, from each shaft, men worked in both directions. That meant 30 sets of men, plus 2 sets working from either tunnel end. So, how do they meet in the middle? You've got 2 problems. They've all got to be digging in the same direction, and they've all got to be digging on the same level, because water don't run uphill. By reading off a number through this level, that I can see in the graticule, crossed hairs, which in Brindley's day would have been made of spiders' webs, I can calculate the difference between my level and Vic's over there. If I continue to do this by a series of calculations up the hill and then down the other side, we can work out exactly how deep each shaft should be. Thanks, Vic.
All right.
Right, we've now got 15 shafts, all down to the correct level, and 32 sets of men heading off towards each other. How do we work out whether they're heading in the right direction? Well, we use a piece of Egyptian technology as modified by the Greeks and Romans. A plumb line, plumbum, Latin for lead. We'll lower this down the shaft. We then, at a small distance, lower another one. Down a bit, down a bit. Whoa! Right. Very difficult to keep these steady because they're both at the bottom of a mine shaft. However, there we go. Although we're in pitch darkness, if we use a candle and align these correctly, because they're aligned with the centre line of the tunnel, which is marked by the poles on the top of the hill, we should all be digging in the right direction. It was an extraordinary feat of engineering, and it took great courage and huge bravado to even conceive of doing this. The newspapers called it the 8th wonder of the world. The subterraneous navigation, which is being cut by the great Mr. Brindley, who handles rocks as easily as you would plum pies. Brindley was amazingly confident. He took a large bet on finishing the tunnel in 5 years. Unfortunately, the work took 11, and by the time the tunnel was finished, Brindley was dead. His extraordinary tunnel is now disused. Disused! 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 I'm actually about to go into a later tunnel built by Thomas Telford, but as you can see, it's got one crucial thing in common with Brindley's tunnel. It's very narrow, just under 10 feet across. And it's this dimension that is Brindley's legacy. This set the standard for the Midlands waterways. This is a narrow tunnel for narrowboats. Up to this point on the canal, Brindley had built to a traditional dimension, that of 14 foot, the traditional Mersey flat. Faced with a 2-mile-long Harecastle tunnel, he came up with this bold decision. By halving the width, he quadrupled his savings on the amount of material he had to excavate from this borehole. A very simple and breathtaking piece of arithmetic. This tunnel would originally have had a towpath. It's now gone because the only boats that go through now are motorboats. So it would also have been almost silent. Very, very eerie, just the sound of the horses' hooves. It's not like the Channel Tunnel when you don't actually have a sense of passing through a tunnel at all. There's plenty of drips down the back of our neck. So digging it must have been pretty extraordinary, but we're used to kind of the tales of the trials of the diggers working under candlelight, all these hundreds of feet underground. But also, what must it have been like for the first narrowboatmen, the people who actually had to make the leap of faith to bring their boats 2 miles under a hill dug by, who did they know? It could have been a bunch of madmen. It must have been a great leap of faith. A bit like signing up for the shuttle. Well, we got through the Harecastle tunnel, but it's still a long way to the Mersey, and it's downhill. Brindley faced the perennial problem of all canal builders: how to move boats up and down gradients. He would follow contours whenever possible and only use locks when absolutely necessary.
Because he'd already set the dimension of the tunnel at 7 foot wide, all boats now on this system are the dimensions of this working boat, about 70 by 7, a ratio of 10 to 1. A narrowboat.
All right. Yeah. Not selling much coal at the moment, no way.
Wrong weather, isn't it? It's terrible weather, this.
In 1777, Brindley's Grand Trunk was finally open, with over 70 locks and 5 tunnels. A fantastic engineering achievement.
His canals opened the way for a massive expansion in trade. Towards the end of Wedgwood's life, he reckoned that business in the potteries was worth £300,000 compared to just £10,000 in his father's day. And up to a few years ago, crates of crockery were still being carried along these waterways.
This all seems peaceful and idyllic, but of course the working boats would have been through here like a dose of salt.
And the boom in trade meant more flint and more clay being brought in from across the country. That meant flint processing could no longer be a one-man, one-mill operation. Large-scale production was the only way forward.
The Etruscan bone and flint mill at the junction of the Trent and Mersey and the Caldon Canal carries out exactly the same process as the old mill at Cheddleton, except now the latest steam engine runs a whole room full of grinding pans. Like this. 10 pans, 60 tons. In 50 years, revolutionaries like Wedgwood had transformed the trade of potter into an industry. Wedgwood's manufacturing innovations were so well executed and so durable that cream, or rather queensware, is still made today. From Flintstone to Wedgwood, the demands of mass production fueled the Industrial Revolution. In the next episode, I'll be looking at the effect mass production had on the textile industry. What are you looking at? Maintenance, is it? No costume on this shoot.